Hi everyone, welcome back to all of you on my YouTube channel. I'm Ankit Mishra. I'm teaching for GATE Chem Engineering from last 4 to 5 years. So I'm continuously putting the video series of PYQ for all of these subjects. So here, this one is the second lecture, second PYQ series of fluid mechanics. That is buoyancy and flotation. So my one request to all of you is that just share this video and among your colleagues, and also subscribe my channel so that it can reach to a better audience and maximum audience. So the best part of this coming with why I'm coming with this PYQ series is that let's say I am solving the questions here in the same way. Let's say I'm assuming that I'm writing for the GATE examination. So what sorts of thing that you should not write on the scribble pad, and what sorts of the thing that you have to write on the scribble pad, and how to save the time and how to optimize your questions for the time for the questions that you will be learning in this also. And also I'll be teaching some calculation tricks during the so when I'll be solving the question. Okay, so this will be helping you a lot for the learning purpose. So without wasting the time, let's just start with the question. The first question says that what is the force required to hold a spherical balloon stationary in water at a depth of h from the air-water interface? The balloon is of radius 0.1 meter and filled with air. Okay, so balloon is filled with air and it is going to placed in the water, right? So what you will see, so let's say if this one is water, and if I am placing any balloon, let's say something like that, okay, and this balloon is supposed to be there up to a height of h. So we want to put, or this balloon is supposed to put at a height of h below the air water interface, and the radius is given to you. So radius of balloon is given. So here I am writing the radius, but in examination you don't have to write, right? So you have to see the screen and you have to do the calculation only. Now, so whenever any fluid is being whenever any object is being placed in the water, and if it is completely submerged in the fluid, then there will be, if you want to apply if you want to make a free body diagram, so there is a upward force on that particular object, and that is called as the buoyancy force, that is applied by the fluid on the object, and this upward force would be balanced by the gravity force, right? So just don't try to understand this. I mean, just don't understand any gravity is happening right now. Just you have to understand how much external, because this liquid is continuously going upward, right? Why? Because the buoyancy force is being applied on the object by the fluid, and in order to restrict the object at a height of h, then you will be applying some force, external force F, on that object. So this F should get balanced by the buoyancy force. So F will be equals to F buoyancy in magnitude wise, and that will be equals to volume of particle that is submerged in density of fluid into Z. Since this object is completely submerged into the liquid, so the volume of object is the whole volume. So that will be equals to 4 by 3 pi RQ multiplied with density of fluid into G. So the fluid is your water, so that will be equals to 4 by 3 into pi multiplied with 0.1 whole Q into obviously 1000 multiplied with Z. So this will get cancelled out, so that can be written as 4 by 3 pi Z, right? So that much amount of force you have to apply from the top or from upward direction to restrict the liquid or object at a height h in the fluid, right? So I think option A will be your correct answer. Now moving towards the next question, and here this question says that a conical tank with the bottom opening of cross-sectional area is filled with water and is mounted on supports as shown in the figure. What is the force F with which plate X must be pushed? So this plate is X and you are pushing this plate with the force F here. So how much force that is being required in order to prevent the water leakage from there? Okay, so let's say the amount of force that you are applying from bottom direction should be equal to the force that which is being applied by this liquid on the from the top y direction. And what is the force which is being applied by the fluid from the top direction? The force will be equals to pressure multiplied with area, right? So since height of the liquid, see, one more thing is that what is pressure here? So pressure can be written as density of fluid into Z into height h, right? Because at every point in the fluid, this is a static fluid, here any point in the fluid, at the bottom point the pressure is going to same. So what is rho f? Rho f is density of water into z, and since density is rho l, so that is rho l into z multiplied with height is capital H. And what is area? So area can be written as area is given to you, right? A, right? So that much force you have sorry, so this one is the pressure, and then you can calculate force, that is equals to rho l zh multiplied with area. So this will be the force that you must be applying from the top direction, so that it will prevent the leakage of the sorry, this much force that should be applied from the bottom direction to prevent the leakage of the water. So option B will be your correct answer. Okay, after that I'll be moving towards the third question. So here in this problem you can see a dam of width 50 meters. So there is a dam of width 50 meter, and height is 10 meter. So this height is 10 meter, and width will be along this direction, right? Width will be along this direction, along that direction. So what is the total force acting on the dam due to the water, right? So since if you see that force is being applied by the water across all the boundaries of the dam, let's say, or along the one direction, another direction there will be only water because dam, and so this, let's say something like that is there. So here water will be filled, so water would be applying the force over here, right? So if I take any cross sectional area element, something like that, cross sectional area element of this particular dam, so having height is, I am assuming, is dh, and area is w. Is that clear? Sorry, width is w. So what is df? df is equals to pressure multiplied with obviously dh. And what is pressure? Pressure is rho into z multiplied with h, right? So I can now write df is equals to integral rho into z into h into dh, right? So I'll do this integration, and height will go from 0 to capital H. So the force that will be equals to rho z h square by 2, and if I'll substitute this integration 0 to h, so I can write rho z h square by 2. So density is 1000 into z df is equals to p into, again there will be some w also, right? So w is your, how much? W is given to you, that is 50 meter. So obviously 50 into z is 10 into h. H is 10 square and divided by 2. So once you do the calculation, you will get 10 into 10 to the power 6 Newton. So that much amount of force that is being applied by the water on the dam, right? So I think from here option B will be your correct answer. Okay, after that I'll be moving towards the next question. The question says that the magnitude of the force that is being required to hold an object, hold a body of volume of the object is given. Let's say if any object is there having volume is given to you 0.05 meter cube, and mass of this object is your 40 kg in water. So density of this object is given, that is 1000 kg per meter cube, and you are supposed to hold this liquid below 0.1 meter, right? So if I make the free body diagram of this object, so there is this object, and along this direction there is a gravitational force, and along upward direction definitely there is buoyancy force that will be acting on the object in opposite direction of the gravity. And since we want to hold this object below 0.1 meter, so definitely we have to apply a force along the downward direction, right, to hold the liquid. So what I can say, F plus, if I apply the force balance over this object, F equals to Fg plus Fb, the net force that must be applied to hold the liquid in that position, that will be equals to F by NC minus F gravity. This is very important. Now when we talk about F by NC, that is equals to volume of particle or object that is submerged into the fluid multiplied with density of object multiplied with G. And since the whole object is completely submerged into the fluid, so what is volume? Volume of the object is mass of the object divided by density of the object. Density of object is not given to you, but volume of the object is given, that is 0.05 into density of the fluid. So density of the fluid is 1000 into z. And what is F gravitational? So that is equals to mass of object into gravity, acceleration due to gravity. Mass we don't know, that mass is 40 and gravitational acceleration is z. Is that clear? So if I want to calculate F, that can be written as 0.05 into 1000 multiplied with 9.8 minus 40 multiplied with 9.8. So if I take common 9.8, I can write that will be equals to, I think, 9.8. So that is 50 minus 40. So that is 9.8 multiplied with 10, which is equals to 98 Newton, right? So I think you will be getting answer is 98 approximately. So option B will be your correct answer. Is that clear? Okay. After that, I'll be moving towards the next question. This question is really important. This question has been asked in 2010, and again this question was also based on the buoyancy force. So you can see there is a hydrometer with stem cross-sectional area. So cross-sectional area of a stem is given to you 2.82 into 10 to the minus 5 meter square. But in actual examination, you are not supposed to write all of these things on the paper. Is immersed in the large vessel containing water and all of these things. The immersed volume here, the volume which is immersed, so means here this volume is given, that is volume of the object which is immersed, that is 15 into 10 to the minus 6 meter cube. And the length of the stem outside of first figure is LW and in the second is LL. And the here density is given, here density of fluid is 1500 and here density is your water, that is 1000 kg per meter cube. And you are supposed to calculate LL minus LW, means length of the object outside of the liquid in the second minus length of the object outside the liquid in the first. So let's say if I am talking about the first diagram and this one is second diagram. So weight of the object is getting balanced by the buoyancy force, F buoyancy, right? So weight of the object we don't know, but what is buoyancy? Volume of the object which is submerged multiplied with density of fluid into z. Is that clear? But what is the volume of object that is being submerged? So that is volume is given to you 15 into 10 to the power minus 6 meter cube. Is that clear? Okay. So what is volume? Volume can be written as here, what this length can be written as what? Let's say if I am assuming the total length is capital L, so that can be L minus LW, right? So it can be written as area multiplied with L minus LW, that is equals to 15 multiplied with 10 to the minus 6. And cross sectional area is given to you 2. So directly from here I can write L minus LW, that is equals to 15 multiplied with 10 to the minus 6 and divided by 2.82 multiplied with 10 to the minus 5. So once you do the calculation here, so you will be getting the value of this one L minus LW, that is equals to 0.532. So let's say this one is equation first. Okay. Now what is W? Weight of the object, that is volume of object multiplied density of fluid into z. Volume of object is given how much? How much volume is submerged? 15 into minus 6 into density is 1000 and acceleration due to gravity is, let's say, 10. So here you can see that weight will be equals to 10 to the minus 4, which is equals to 0.15. Now weight you know. Now if I am coming to second object, second figure, so there again weight will be equals to volume of object submerged in second multiplied with density of fluid into z. So what is weight? Weight we have calculated 0.15 here. Weight is 0.15 that is equals to volume of object that is submerged here is what? L minus LL. And what is cross sectional area here? That is again 2.82 into 10 to the minus 5, because cross sectional area is not going to change. Same object is there, but only length is going to get vary because change in density. Multiplied with density of fluid is 1500 into z. So here only we have to calculate the value of L minus LL. So L minus LL, that will be equals to how much? 0.15 divided by 2.12 into 10 to the minus 5 into 1500 multiplied with 10. So the value of L minus LL from here you will be getting is 0.354. This is as simple as that. So this one is my equation first. Second, so we are supposed to calculate LL minus LW. So if I do the first minus second, I will be getting LL minus LW, that is equals to 0.532 minus 0.354, and that will be in meter, I think. So that will be equals to 0.178 meter. So you are supposed to calculate in millimeters. So LL minus LW, that is equals to 178 millimeter. So you are supposed to calculate LL minus LW, right? Not LW minus LL. So you have to be very careful about that here, because in option there is minus 177 and 177 both. So it may confuse you. So from here your option B will be your correct answer. Is that clear? Okay, so this question was I can say that it was the toughest question on the buoyancy. But again, if you know all of these concepts, that how you can balance the gravity force and the buoyancy force, then definitely any kind of questions that if they are asking any kind of questions from this topic, you will be able to solve, right? I hope this is clear to all of you. After that, I'll end this lecture, and in the next lecture, I'll be starting with the fluid kinematics, and so on and so forth. I'll be completing the whole PYQ series within very small time of interval. So the most important thing that you can learn from here is just try to understand how I am solving this question and how I am trying to avoid the calculation strips here. That is very much important to solve the gate examination, and you have to understand all of this data that with the unit. That is also very important. Unit is very important. Calculation, accuracy is very important, and how fast you can do the calculation, that is also very important. Then only you can score good marks and you can get under 100 rank. Okay, thank you. See you all in next lecture.